Hello students, in this lecture I am going to discuss about 8051 microcontroller pin configuration. So previously in my previous lectures also I have told you that 8051 microcontroller is available in a variety of packages, IC packages like 40 pin dual inline package or 44 lead PLCC and TQFP. That is, this 8051 microcontroller is present in the market in a variety of IC packages. This is the 40 pin dual inline package and this is the 44 lead PLCC. This is 44 lead TQFP. So this I have already discussed in my previous lecture. Now, as you can see, if you compare all these IC packages, if you compare this 44 lead PLCC, 44 lead TQFP or this 40 pin dual inline package, you will notice that the pin orientation of this 8051 microcontroller will change with the package, or it may change with the package, but the pin configuration is same. Again, I am repeating, the pin orientation of an 8051 microcontroller may change with the package, but the pin configuration is same. That is, if you see in this 40 pin dual inline package, the pin number 1 is for P10, then 2 is for P11. In the same way, if you notice this 44 lead PLCC, the pin number 1 is NC, pin number 2 is P10, pin number 3 is P1.1. Similarly, if you notice this 44 lead TQFP, the pin number 1 is P1.5, pin number 2 is P1.6. So all this pin orientation is varying with the package, but the pin configuration is same. That is, if you notice the configuration, that after P10 it is P11, then P12, then P13, then P14, then up to P17, then we have RST, then P30, 1, 2, 3, 4 up to 7, then XTAL2, XTAL1. Similarly, this whole pin orientation will remain same in these two packages also. Just notice here P10, then P11, then P12, P13, P14, P1 up to 7, then RST, then P30, then up to P37, then XTAL2, XTAL1. So this is all remaining same. The pin orientation is remaining same in all the packages of 8051 microcontroller. Again, see, for this 44 lead TQFP, the orientation is P10, then P11, P12, P13, P14 up to P17, then we have RST, then P30, then P31, 2, 3, 4, 5 up to 7, then XTAL2, XTAL1. In this way, the pin orientation will remain same in all the package. So this image is showing the 8051 microcontroller with 40 pin with respect to 40 pin dual inline package, and since it is a 40 pin dual inline package IC, each site will contain 20 pins. And these are the other packages of 8051 microcontroller. As I've told you that this is 44 lead PLCC, this is 44 lead TQFP, and this image shows the pin diagram for these packages, that is 44 lead PLCC and 44 lead TQFP. Now we will see the 8051 microcontroller pin diagram. That is, we need to understand the function of these pins. Hence, we will now see the 8051 microcontroller pin description. So for pin configuration, we will be considering this 40 pin dual inline IC package of 8051 microcontroller. Now if you notice this 8051 microcontroller pin configuration, you will notice that this 8051 microcontroller have 4 ports for input output operation. 4 port means this port 1, then we have this port 0, port 2, and then we have this port 3. So all total there are 4 ports in 8051 microcontroller for input output operations, and each port is comprising of 8 bits which can be configured as input or output. Hence we know 8051 microcontroller has 40 pins, and out of this 40 pins total of 32 pins will work as input output and will allow the 8051 microcontroller to be connected with the peripheral devices. So this 32 input output port pins will allow 8051 microcontroller to be connected to the peripheral devices. So the 4 ports P0, this 4 ports P0, P1, P2 and P3 each use 8 pins. You see P10, then P11, P12, P13, P14, P15, P16, P17. So this are the 8 pins of port 1. Similarly, we have 8 pins of port 0, 8 pins for port 2 and 8 pins for port 3, making them 8-bit ports. And so all the ports upon reset, when the 8051 microcontroller is being reset, so these 8 ports are configured as inputs and they are ready to be used as input ports. When the first 0 is written to a port, it becomes an output, which means what I'm trying to say is that when 8051 microcontroller is being reset, the ports will work as input ports. They will receive data from the peripheral devices. Now, if I have to configure any port into an output port, I have to write 0 to that port so that it becomes an output port, and to reconfigure that port as an input port, I have to write 1, that is 1 must be sent to the port so that that port can be configured as the output port. Now let's talk about port 0. Then we'll talk about all the ports like port 1, port 2, port 3 and port 3 up to. So let's talk about port 0. So this port 0 occupies a total of 8 pins as I've told you, and the pin number is from 32 to 39. So this port 0 is occupying the pin number 32 to 39. It has a total of 8 pins. It can be used for input or output. To use the pins of port 0 as both input and output ports, each pin of the port 0 must be connected externally to a 10 kilo ohm pull-up resistor. As you can see here, each pin of the port 0 has been connected externally to a 10 kilo ohm pull-up resistor. This is due to the fact that port 0 is an open drain, unlike port 1, port 2 and port 3. Open drain is a term that is used for MOS chips in the same way that open collector is used for TTL chips. So in any system using this 8051 or 8052 chip, we normally connect this port 0 to pull up resistors. In this way, we take advantage of port 0 for both input and output. Now, with resistors connected to port 0, now if this 10 kilo ohm pull-up resistors are connected to each pin of port 0, now it can be configured as input or output port. So in order to make it an input port, this pins of port 0, in order to make the pins of port 0 an input port, the port must be programmed. As I've told you previously, how we can make it an input port, we have to write 1, and to make the pins of the port as an output port, we have to write 0. We have to write 0. So in order to make the pins of port 0 as an input port, the port must be programmed by writing 1 to all the bits. So this is the code. In this code, port 0 is configured first as an input port by writing 1s to it, and then data is received from that port and sent to P1. So let's see the code. The first what we are doing, we have written 0FFH to the A register, since A is a 8-bit register. So what is this FF? FF is 1111 1111. if you write this hexadecimal FF represents the hexadecimal format. So if you write FF in binary form, it is 1111 and 1111. So we are writing 1111 to this register A. Now we are moving the content of register A to port 0. Port 0 is also 8-bit port, and this register A is also 8-bit port. So this all 8-bit will get transferred or will get copied to port 0. So all the pins of port 0 is now 1111, and as I have told you, to configure any port as an input port, we have to write ones to it. So after writing ones to the port 0, it will work as an input port. Now next step, what we have done, we have transferred what we have done, the next step is move A P0. What this step will do, this step, since now in this step port 0 is working as an input port, the next step, what is written here, the next step is the data of port 0. Since port 0 is working as an input port, so the data of port 0 will get transferred to this register A. That is, this step is showing that get the data from the input port 0 and copy it to the register A. Now after the data from port 0 is copied in register A, the next step is we have moved or we have copied the content of register A to the port 1. So in this way, we can, what we are doing here, we are configuring port 0 as an input port, and we are getting or receiving data from this input port 0 and moving it to a register. So this is how you can configure any port into an input port, and for configuring that port into an output port, we have to write zeros to that port. So we'll continue with the same lecture in my next class also. I'm ending this class here. Thank you.